Hey, good evening, gang. Welcome to another masterclass. Um, so tonight we are exploring the concept of dry code. So don't repeat yourself is what dry stands for, and repository structure. And we have the lovely Atlas who's going to be running through this webinar. Atlas is usually based in Perth, but is joining us from Sydney this evening. So I'm going to let Atlas introduce herself. But I'm really excited to find out more through this masterclass. We just had a quick whiz through some of the slides, and you're in for a very beautiful visual treat this evening. As always, if you've got questions, please pop them in the chat or reach out on Slack afterwards if there's anything that you don't understand. We're going through, I think from what I understand, we're going to go through quite a bit today. So if anything goes over your head, then that's all good. We're here to answer questions. So without further ado, I am going to pass over to Atlas so we can get dry.
Hi, I'm Atlas, and so I've been a software engineer for 7 years now. I'm currently working as a senior software engineer for a mining company in Perth. I used to base in Sydney, and yeah, so I will be going over what dry principle is and repository structure and why it's important. And then towards the end, I'll do a little demo. Shall we start? And oh yeah, throughout like the whole presentation, like please feel welcome to like ask any questions. I do want this to be like a bit more interactive. And it really does help me if you can have your camera on if you're just tuning in. Yeah, it just really helps me with who I'm speaking to and like just being able to see people. So thank you so much everyone for turning on your cam and don't feel shy. And if you have any questions, please just ask. Maybe have a little emoji like hand so I know if there's like too many questions, but yeah, we have a small like team today. So is it okay if I go on with the agenda? Yeah. Okay. I'm just like 7:21. I need to like keep track of time so I don't go over time. Yeah, so this is the agenda. I'll go over what dry principle is and some of the important concepts of dry and how do we use dry with examples that I prepared for. And then the fourth item is an example of a directory structure. And then lastly, we'll like do a walkthrough and a freestyle demo of an example, a simple Python like example. Does anyone have any questions? Okay. Yeah, please don't feel shy. Um, if you do have any questions. Okay, so what is dry? So I put this like little image because I thought it like really represents what dry is. You can see like he's like repeating himself so many times and you don't want to do that. So it stands for don't repeat yourself. And then so the whole concept of dry is that it as a developer or a software engineer, it helps us when we're developing it. We want to reduce repetition of patterns and reduce like the code and logic duplication. And the main thing is that we want to write it once and be able to call it once. So we don't want to repeat yourself so many times and then you have to like call in so many different places. Um, is there any questions regarding to like what dry is? It's pretty like I didn't want to like make it super complex, so no, all good. Okay. Has anyone used dry before? Just curious. Okay. Is everyone like familiar with Python? Yeah, okay. Just a little bit. Okay. All right. So dry principle, it's basically a concept, right? But then there's there's a couple of like ways to do it and why we do it. So I've like jotted down like six main like reasons why. why do we use dry concepts? Sorry, I need to do this. So the first one is you write like a line of you write a function and you can reuse that function multiple times instead of because the function like you have like logic inside of the function and you don't want to keep on writing the same logic in different places if you need to reuse it. So that's like code reusability. Trying to think of an example. Okay, can't think of it. And then the other thing is that you want to have like one single source of truth. And that basically means I'm just doing a high level overview as we'll like continue on with the slides and it'll have like specific examples. But then source of truth is how you write it once and then you can call it from that one place. And it helps us like as a developer and engineers like better organize how where everything is at and how the code is structured. And then the other bit is the magic numbers and strings. Has anyone heard of magic numbers and strings? No? Okay. So magic numbers and strings, they basically they're like static hard-coded like it could be a string, right? So it's like you statically and you hard code that one string and then you maybe you need to have it like in multiple places. So we'll see like how we can like use the dry principle and just like call it once. And then the other thing is modul I can't say that. Module it's the S that's tripping me up. You wanna so that basically means separate out like concerns. Module why can I not say that? Maybe Kate can help me pronounce that.
Modularization?
Yes, okay, there you go. A very hard word for me tonight to say. So that just means that you want to have like a lot of because as your program um gets bigger, it gets really difficult to work with, right? Even for like as an individual developer or an engineer, you have lots of code everywhere and you want to be able to package the business logic and you want to be able to package or and organize like logic into its own module basically so that could be broken down into like quite low level like into its own function but then a bit high level will be like how do we organize folder structure so that we know exactly where everything is. So it's like just keep your house like organized so you can see your code as like your own like house and you want to be able to organize them into its own compartments. So that's that. And then the other reasons why we want to use dry is that we keep our code clean. So all of these other, oh, I missed the abstraction. So abstraction, um, I'll go over it during this master class on a quite high level. Um, so everyone can get a feel to what it is, but I won't go into detail because there will be a more in-depth master class that will like cover what abstraction is about and how do you use it. Yeah, so the last one, clean code. So all of these will help you be able to maintain your code in a nice, organized, like clean way, just as like if you were having if you just like if you were making sure that your house is clean, like that's like another analogy to it. I'll just go over to the next. slide. It will make more sense once I go through the slides because I'll go through like each concept. Um, so throughout this master class, we'll like go through each of the concepts that I've like just gone over. But it will slowly with examples, and these examples will like help us like it will like build up to how like it will like build up to building a simple like e-commerce app in Python using the dry principle. And then I just put like two main things that I would be covering in the walkthrough and the demo. So these like the calculations like tax or subtotal and total, they'll be like using a function to do that. And that keeps the code clean and also separate out like the logic and concerns. And the other main thing is that we'll go through like maybe like order, like when someone when someone places an order, how do we like code that, and how do we make sure that we're following the dry principle? Like, and then I'll go over like importing from different modules and calling from like the functions that we'll be creating. And lastly, I'll go over like if we have time and if everyone is like still awake, I'll go over the abstraction part. So that's the last thing. And throughout, I guess in between, I'll go over the directory structure. So yep, so this is the slide for code reusability. I'm just checking the time. Okay. So that's the first concept of dry, like why do we use it and why is it important? So we want to follow like dry concept because it helps us reuse like code. And to do that, we create functions that has similar logic, or if a function that would do one particular thing. So that's a basic baseline concept of like why do we create function, and uh why do we create function in terms that a function would just do one particular thing. And with that logic, like like what how do we name the function, right? So in this example, just handle like common operations like calculating total price in relations to like building up to the simple like e-commerce app that we'll like do later on. So I got like these two examples here. um Pronoun move. Okay, sorry. Okay. Um, so this is an example. It's on the right hand. Okay. The no dry example. So I got like these two. Actually, I'm gonna go through the dry example so you guys can see, and then you guys can see like what what happens when we don't like use a dry exam concept. So in the dry example, I've created, I have an item. So these would represent like the items being ordered or has been placed. So it'll be inside of an list, and then it'll have like dictionaries that represent each item, right? So you can think of it as like um Kate has like placed, she wanted to buy like laptop and a mouse, and that's the pricing for it. And then these are the quantity that she wanted, and this is like for Kate's like order placement. So you can see it as that. And then here, I've created a function. It's called calculate total price. So in calculate total price, um, inside I have a logic, right? The logic would only calculate. I just want to get the total price. So in the total price from the items that's been placed, Um, so that's yeah, so was there any questions regarding to this? Okay. Yeah, so the idea is that in the logic, I'm just getting each price of the item. So in the dictionary, and I'm adding it up so I can actually return the total price. You can print it out or log it out as well. But that's what this function will do. But then, so that's like me putting the logic inside of function. So I'm not repeating myself. And if I don't follow dry, or if I don't implement the dry concept, I would have something like this. So I would probably have like a function called view cart, and then or like process order. But then inside of that, I would actually like calculate. I would have the same logic as like total price, and then I'll like repeat myself if you guys can see that in the code. So like why am I re-copying? Well, I guess like I could copy and paste it into the places that I want to use this particular logic, but why am I like repeating myself like throughout the places when I could just put that logic in a function called like calculate total price? Um, any questions regarding to this slide before I move on? Okay. So avoid magic numbers and strings. Okay, so this one in the no dry example, I have a function called calculate tax, and then inside can see, so let's just say that the tax rate is like 7.5%. So I have hard coded 0.075. So I've hard coded the actual like tax rate in sorry, float. So that's what it means, like magic numbers and strings, because this particular like no float, maybe I need to like call it in different places. So if I'm hard coding it, I need to, in other places, I need to like type in 0.075, and then and calculate tax, and then or like in total I need to like type it again or like copy the same number. And that when I'm doing that, um I might like make a mistake, like a spelling error, like I might put 7.6 instead of like the actual tax rate. So in the dry example, I have defined a constant. So the in so the naming convention in Python for constants, it'll all be like capitalized with underscores. So I've defined 7.5, and then in the function, I'm just like calling it in like as I just call the tax rate, and then I divide by 100. So it gives me the same number that you see in the no dry example. Um, can anyone like tell me like I guess like the advantage of defining this float as a constant as like defined in the dry example?
I guess if you have different calculations or different parts of your code where you're referencing the tax rate, if the tax rate changes because of, I don't know, regulations or whatever, then you don't have to control F and find it everywhere. You can just change it that one line.
Yeah. So that's exactly. You're like, yeah, that's right. Yeah, so that's so when you not following the dry principle, it will like um can you help me pronounce your name? Afira?
Afira, yep.
Yeah, yeah, exactly what you've said. It when you have to define it in multiple places and you're hard coding it, it will like lead to bugs and inconsistencies when there's like a change across like all code. Yep. So does anyone have questions regarding to this? So this is an example for
Is it
flow.
the same? Oh, sorry, sorry.
No, it's okay. You go
Uh,
ahead.
Is it the same as a global variable?
Yeah, so this would so a global variable, so in Python, remember the syntax, you can specifically like say you type in like global and then
Mhm.
it could be spread throughout. I think it'll be able to call it inside of the same file. I need to double check because I haven't used that particular syntax. But in this example, if you're defining it within the file, you can like call it. But then if you define the constants in like in a different file, you would have to import that file over. Oh, I was gonna
Thank
say,
you.
yeah, so this is like example for flow, but this would relate to like hard-coded strings as well, or like int. Okay, move on. Oh, this is the tough word that I'm not able to pronounce. Marginalization, there you go. Okay, so this means it's you're separating out like concerns. I mean, the whole principle of drive really follows like separating out like concerns because when you're defining a function, you want to like put the logic and that only pertains to that function. So, um, but for this one, you're actually, yeah, you're breaking your code into like modules. You can see modules as like functions again, according to their responsibilities and related like logic. Um, so a function should only do one thing. And so that's the function side of it. But then with modules, you can, um, because you can have like a folder and then inside of that folder, you can have like different like files, right? So each file could do like you can also see files at its own like module. That file like does one thing. For example, like the file could be like it process like order, and then the other file will be like shipping. So in that shipping file, it will only like have all the responsibilities relating to like shipping. And you can have another one. It could be like um maybe like customer dot py. So that file would only have like it would like maybe process like it would create customers instances. I don't want to say that. Okay. So it would like so you can separate out like responsibilities based on like files as well. Or that's like interchangeable like file names. You could see that as a module and each file according to that file name it would only handle that particular thing. And then with this, oh, oops. With this one. Yeah, so this would be dry. So I've put down like I've commented the file names. So in this example, I put all the constants that will be reused throughout the code inside of like a constants.py file. And then what I would do is because all these calculations, I would just call them like utilities, right? That's like that's a standard file that you can use utils.py and then you can put all the utilities in this particular file that other modules or files would need to use. So in here, I just imported what I needed, which are like tax rate, shipping costs, and maybe even discount rate from constant. So when you're importing, you don't need to specify like .py, you just call the module name or the file name. And then in here, I have like bunch of utilities I could use. It could be like for this example, because we're kind of building up to an e-commerce app, it's like calculating like price and stuff, apply a discount. But then another example would be like in utils, it could be like get hex like color code. If something for like Canva or something. That's just another example. And then in the no dry example, yeah, can anyone spot like what's the difference between like the dry example and the no dry example?
You've defined, oh, sorry, you go,
Yeah,
Abby.
you go. That's okay.
No, you go, you go. I've already
Oh,
did it once, so it's your turn.
okay. I thought no one was talking, so I tried to. So I think from the difference from no dry and dry, with the dry, you kind of define the variable or constant once, and you can reuse in the functions below, and you just don't have to keep typing a different number. And then at one stage, if you want to, for example, change the text rate, you just need to change the constants once, and it will apply to the functions below.
Yep, exactly. Yep. So yeah, in the no dry, I'm hard coding it again, and then and it's all in one file, but then in the dry, exactly what you've said, Abby. Cool. So everyone is paying attention and being interactive. Okay, this is great. So the other important concept of dry is that we maintain a single source of truth. So the source is defined in one place, and you only need to update it in that one place when you need to make changes. Let's look at the dry example. So it's similar to the previous examples. Yeah, so it's similar to the previous example. I'm trying to see. Calculate tax. Okay. Yeah, so the dry example, it's quite similar to the example that we just saw, but the no dry, it's so similar. But then here I think I just repeated myself again with the tax rate here, 0.075. That means that you can see, let's just see that like these two functions in the no dry examples, they're in separate like files. So they're in file A, and then calculate taxes in file B. And then now you need to like update it in both places instead of like just one place. So the dry example, you just go into where the constants are defined, and then you just update it. That's one way to do it. Um, I'm trying to think of another example. Yeah, so another more high level example would be that does anyone use GitHub here or any version control system? Yeah, okay. Um, so in another more high level example would be that you have one code base, for example, a code base for like an e-commerce Python application or like a Python script. So you have that in GitHub, right? And everything is up to date. Then somehow for some reason you also have that like you have that on your I guess like, okay, somehow, for some reason, someone from your team decided to, they weren't aware that the whole team was using GitHub, so they've uploaded into a different spot. And now there's no, it doesn't really follow this principle anymore because there's no single source of truth, as in there's two code bases in different spots. So it really creates inconsistencies and like it'll be really hard to maintain. So for that, it will just be better to have that one code base and one version control, and then you have that entire code base as a single source of truth. Okay, abstraction. Or is anyone familiar with abstractions or classes? I'm just trying to gauge a little bit. Has anyone used classes before? A little bit, okay. Or none, okay. So abstraction, it's a big concept would be that so when people are saying like, let's abstract everything away, that because when we start off, it's like functions, and then how do we do like a bit, how do we do abstract, how do we do more, so like abstraction is a concept that we can use. It's basically a technique, and in terms of that is that we create like classes. So that's one big concept of what an abstraction is. So it's basically a creation of a super class, and then in this example, you can have a class of like customer. So from that class, a customer could have like customer ID, customer first name, customer um, surname, phone number. So these are like attributes to a customer. And then you say, hey, these are like my blueprints for that customer. And then from that, you can like, from that blueprint, you can create like a lot of customers. You don't have to create like a customer, like a custom, like customer code for each one of them. You can just like use the abstract customer class. So in this example, it would be like order, you can have create an order class, and then from that you can have a lot of instances of like the order class. So basically it generalize and simplify like a lot of the concepts. So that's what I have in the class order dry example. Um, so with this, maybe like the class order would really, all of the order would have like a status. So I would say, okay, I want to have like an update status in this class, because every order would have to update their status, and every order would produce or generate an order summary. So because every order would have that, I put it in the order class. And then in the no dry, you can see like I've repeated myself like many times. And then I'm also repeating calling the functions many times, and um, I need to hard code, or I need to define like the order number in here. And the thing is that in the no dry, um, I have order one and order two, but like, how do I know that they all follow like the same pattern of order? So that's where like the class order would come in, because as a developer or an engineer, like you set that blueprint. So anything that is inheriting from that parent or the class, like they would all have the same blueprint. No, oh, like we have like 15 more minutes. So clean code, I think we've like been talking about it and like interacting with the slides throughout the class. So overall, following dry principle, it helps us to like maintain a clean code, just like how you will like clean your house and your room. You want to make sure that your rooms and your house is clean, so it's easier for you to work with, and you just have a better like space when you're developing and programming. So I got a dirty code example and a clean code. Can anyone tell me maybe just like one if you can spot why this is a clean, like this is a cleaner code, and why this is like a dirty code? Um, in here actually, I'll let you guys have a think about it really quick while like I go over what this enet is. So in this class order, I have like enet that basically means a constructor. A constructor means that every order would need to have these attributes. So every order would have order ID, order customer ID, and like in this pattern, I did pass in the items that the customer would order. And then I say the default status is just pending. I think it should be, yeah, that's how I've set it. So every order must have these 4 attributes. And just some calculations that pertains to the order. Yeah, can anyone spot? There's one little thing that I did put in the clean code that's very different from the dirty code. I can give you guys a hint. So it's in the constructor. If you look at the parameters. Okay. That's just one thing I put in as, but there might be other ones, but I think we've already gone through it, and then you guys were able to answer it correctly. I'll just let you guys okay, so one thing with the dirty code, I pass in, if you look at the constructor, I pass in the order number. But if I'm passing it in, like, I guess the first question is where does it come from? Because order number needs to be unique, right? I could hard code it like what I did in the previous slides, like here. I could like 1, 2, 3. I could do that, right? Or I could create a function that will generate a random number, and then I could pass that in. So this would be a dirty code for this particular example that I'm talking about, because I'm passing in and there's hard coding that I might need to do as the order number. But in the clean code, I'm just using a UUID, like a generator that will generate it. So every time when I create a new order, it will have a new UUID, and then I don't need to pass it in. So that's one little like example. But the other ones we've already covered. So was there any questions regarding this before we move on?
Hi. Just another thing. Oh, can you hear me okay?
Yeah.
Yeah, cool. So the dirty code with the calculate total definition appears to have like 3, I think, separate calculations in it. I assume that is it better for a something that's defined to just do a single thing?
So in the dirty code, okay, there's calculate total, and then there's yes, that's the other thing. Because it's doing multiple things. Yeah. So and so you would want to separate out the logic, because essentially you would be, does anyone know the keyword? When you separate out the logic, you're essentially
Modularization.
Yeah, or like separating out concerns and you're following dry principle. Yeah. Was there anything, questions, or maybe you wanna nothing? Yeah, that was a good one, Catherine. Thanks for spotting that. Okay, we'll move on. So we have about 15 more minutes. Directory structure. So I just put like high level of why it's important for us to clean our directory and make sure everything is organized. So one reason is that it's easier to maintain, um, especially when you are working with other people and collaborators. Um, and then the other one is, yep, so when you're collaborating with other people, people might not be able to know where things are, but then if you follow, I guess, the standard structure within the team, the standard structure of what your team has defined, it makes collaboration a lot easier so everyone knows like where the, I guess, like the cups are, the spoons and the forks, right? So you put them in like a forks folder. That's just another analogy to it. And then modularity, you have different folders that represents modules, and then you can easily spot this is where I need to make the change, um, or this is a bit where I need to create this new feature or component. And then the other thing is that testing, because usually you would have a test folder, and then in the test folder you would have perhaps like different categories of testing, like unit testing or regression testing, user acceptance testing. So you would kind of organize that into its own folder structure within. And then deployment, so you would have all the deployment component within um, a folder, or you could have it like just at a spot where everyone knows where it is. And then documentation, usually it would just be like a big readme, but just, yeah, one file. Unless there's other like assets that you want to remember or note, or to let your teammates know, you could have another folder like that's assets, and then in there you could have like, I guess, other documentations. Okay, so I've just created, this is an example just pertaining to the e-commerce Python app. So in here, I have an e-commerce folder, and then I have this underscore init underscore dot py. Does anyone know what this is for? What this file is for?
I don't know what it's for, but I'm assuming init is shorthand for initialize.
Yeah, okay, so it is initializing something. So it initializes this. So, because this init is under the e-commerce folder, and it's initializing this directory as its as like a module. So it's telling Python that, hey, I want you to know that e-commerce folder is a module. So when it recognizes that it's a module, you can maybe in test, like in another folder, you can import that. So I've actually learned this today. So with this file, so it's only, so if you're using Python 3.3 above, you don't need to define this. So, but then if you're using Python 3.3 below, you do have to initialize it. You can test it out on your own time if you like, but let me just continue. In here I have a folder called utility, so just have a bunch of utilities in there if I want to. And then in here I have like an order folder. So that's how, you can see that things are organized in its own like folder, and it's easier to like know, hey, if I need to add a new utility, I just go to the utilities folder. And then if I need to, for example, I need to process like order or like ship order, I could put it inside of the orders folder. Essentially, it's up to you as a developer and engineer to decide what's the best way to organize your code. That would follow like these concepts, right? Like how do you make sure that it's maintainable and easier for people, not just you, to collaborate onto the code, and then how do you make it modular? So I've seen like throughout my career, I've seen like a lot of different like folder structures. But these would, if you see it as a high level, this would be like more of the high level like default like folder structure that most like engineers would follow when they're working with other people. Okay, so we have like 10 minutes. So I'm gonna do a walkthrough and a demo using the dry principle. Oh yeah, Freud said thank you. Okay. Let's do is everyone like okay for us to do a walkthrough and a demo? Do you guys want to you guys want to see me demo? Okay. And I do invite you to also like walk through it as well. It just helps like to practice and stuff. Okay, let's see if I could do this within 10 minutes. So I do invite you to pull out your like terminal IDE, like Visual Code, if you want to follow along with it. Okay, let me just let me being recorded. Stop. Let me just stop sharing and then so I could adjust. Okay. Okay, how do I do this? Mm, oops. Code. I'm just gonna share my screen now. Share screen. Welcome. This one, try demo. Okay. Can everyone see my screen? Is it the demo dry one? Okay. I'm just gonna have my terminal like underneath it. So in here I will create. I'm gonna have the slides like on the screen, so I'm like kind of following along with the slides as well. Mhm. Okay, yeah, so in here, I'm just going to create, I will create like a utils like folder, so utils, and then in utils, I'll just create a file called utils.py, so it's in here, and then I'll create a readme, so that would be my documentation. And then I'll create a main, so a main dot py. So in main, we're probably not gonna be able to go cover a lot, but in main, is anyone familiar with this syntax? It's just that, right? Yeah. Is anyone familiar with this? Okay, so I think I'll try to cover this because it's quite important. Okay, so this one, I'm just gonna, so what happens is that without that, right? So if I just do like a print hello world and then I run this main.py. So what happens with this is that Python internally, it's going to assign the name scope to main.py to this file. Sorry, is this in, oh, everything is in util now. I need to move it. Why is everything? Oh, it's okay. I didn't want this to, I need to come out of it. Let me just move this. Okay, it is out now. Yep. I'm just gonna cd file, and then we'll create like a folder called utils. Okay, so I'm still in main now. So with this, I'll just say this is from like main.py. And then in here, I'll just, so I'm still in main.py file. And then in here, I'll just create like a function that'll be my func. And then I will print how hello. This is my my func from main.py, right? Okay. You'll see, so this is what I have in main.py, okay? Then in here, I'm gonna create another file. I'm just gonna say like script or something. Actually, so in here, I'm going to, so this is what I have in my main dot py, and then in script, I'm going to like, I want to call my func, should be my func, like this function in script. Does anyone know how to do that? So this is like, you can see main.py as its own like module, and then I have a function inside of it. but then I want to be able to call this function in a different file now.
Is it like import from like main? You got to call the function. I know that much, and I know you write import.
Import.
Yeah.
Okay.
Yes.
I have a error message. So it would be from.
Should I be from the main.py and you import that function, which is my font?
Yep. So from main, and then now what's the function called again? So this would auto like complete for me. So now I can call it. Actually, what I'm gonna do. I'm gonna return this string. Okay. And then in here, so I'm gonna call this function. I'm just gonna call it as, and then my func, right? And then I'll just print it out. So so if I run script.py, it's going to give me this, right? Script. I think we have just one minute. Do something. Okay, so yep, so it did call the function and then printed out what I wanted. And then now I'm coming back. So we done the import module successfully, and then now in main.py, if I run main.py, it's going to print out like, actually, it's not going to print out my func. I need to call it here. And then I'll just print it out as well. Actually, I could just do this. Print, bam. And then, so this is when I call this, it's gonna print line 2 and 6. Bam. Okay. So this thing here, this syntax, it's basically letting Python know that this file is my like main module. So it helps with this line 4, it helps separate out concerns again. This is a small example, so it's a bit hard to see, but essentially, like when you define this, you're letting Python know that this is my main module. That's how I would simplify everything and see it. And yeah, so I guess another way would be that I just ran script.py, but it didn't print this out, right? It's because of this particular syntax. And that's how I want to keep it that way, because I don't want this script.py, maybe it's like a util file. Like I don't want it to be main, because in here, because if I'm defining this as my main, you can see this as like the first point of contact when where the app starts. So usually it would be like a main like function here. Yeah, we're like 2 minutes over time, and I think we imported modules, and unfortunately we didn't get enough time to go over the demo, but if Kate is okay and if everyone is able to stay for 5 more minutes, I could just quickly like show like just kind of like overview of the slides that we went through. Is that okay? And are you guys okay with 5 minutes? Okay. And is Kay okay with that? Is she still here?
All good.
Okay, I'm gonna take, okay, cool. Cool. So with that, because from the example that we saw, so I'm going to define this as my main, right? And then so I'm gonna change this into like I'm gonna call it like the utils.py, and then I'm gonna put this under util. Just for the simplicity of it, but to really simplify, I could just have the utils.py instead of having it in a folder because this is such a small, like simple app, there's not going to be many different utils. Yeah, so in here, this is where I'll just do a quick demo function. So we'll just calculate the subtotal, right? And then from the slides that we've gone through, we need to define like a constant. So we'll do constants.py. And then in here, I could like define the tax rate, which I'll just say 7.5. And then in here, calculate, so subtotal initially will be 0. And then how do I calculate so subtotal would be just the item price. And then I'll do a little note here. Let me copy the items from the example. So remember this item example that we went through on the slide. So in here, I will pass in the items, right? To get the subtotal. And then oh, you guys are welcome to help me out as well. So I need to loop because this is inside of an array, so I need to loop through it. So I'll just do that. So this will loop through each dictionary, and I just want to add it up. So subtotal equals item and then price. So I'm gonna do a shorthand. So this is like a shorthand plus equal, which basically means like subtotal plus that. So that's the shorthand for it. And then I need to times the item, not quantity, right? And then I will just, so in the for loop, I'll just add everything up and then I'll just return it. Okay, so I want to ask, I got this tax rate. Oops. I think it should have been tax because that's the example, calculate tax. Total. And then in here, I'm gonna get the total equals to subtotal. I'll just get the subtotal and then, or it could be total and then times. I want to get because I want to times the tax rate divided by 100. Should be. How do I import the tax rate again? So I got the tax rate defined as here. And I want to import it here.
From constant import tax rate?
Yeah, import tax rate. So that's one way. I think the other way is you can just import constant. So when you do it this way, so that means that you might have like other like constants, right? It could be that discount rate or something. So for example, you got lots of it, and then this way, so because you might need to use a constant like the other ones, and you don't want to keep on importing all individual constants. So you could just import the entire like module. But then in this case, it's complaining right now because it's not defined. So you just do this and that will like fix it. It's 5 minutes now, so I will like end the demo. I hope everyone like learned something and had a good time. Let me just stop sharing now. Thank you so much.
Thank you so much for
Thank
running
you.
through that, Atlas. I will stop the recording. But if